In this video, we will be talking about lesson 3.6, which is cubic identities. This lesson is on page 88 in the textbook. So there are three main cubic identities that we'll be talking about in this video. The first one is, what is a plus b cubed? So to do this, you have to first write it out as a plus b times a plus b times a plus b. Then you multiply these two a plus b's together using the identity for multiplying two binomials together. This gives a squared plus 2ab plus b squared times a plus b. Then finally you multiply these two terms together using the same method we use for multiplying two binomials together, but instead this time it's with a trinomial and a binomial. So what you do is you first multiply this term by every term here, then you multiply this term by every term here, and then you multiply the last term by every term here. So multiplying a squared and a gives a cubed. Multiplying a squared and b gives a squared b. Multiplying 2ab plus times a gives 2a squared b. 2ab times b is 2ab squared. B squared times a is ab squared. And b squared times b is b cubed. So then you can combine these two terms and combine these two terms, and you get a cubed plus 3a squared b plus 3ab squared plus b cubed. The next identity that we'll be talking about is a minus b cubed. So you do the same thing here as you did in the previous problem. So this is a minus b times a minus b times a minus b. Then you multiply the first a minus b and times a minus b, and that gives a squared minus 2ab plus b squared times a minus b. Then you do the same thing as you did in the previous problem. So a squared times a is equal to a cubed. A squared times negative b is equal to negative a squared b. Negative 2ab times a is equal to negative 2a squared b. Negative 2ab times negative b is equal to positive 2ab squared. B squared times a is equal to positive ab squared. And finally, b squared times negative b equals negative b cubed. Then you combine these two terms and these two terms, and you get a cubed minus 3a squared b plus 3ab squared minus b cubed. The last identity that we'll be covering in this video is the identity x plus a times x plus b times x plus c. So first what we do is we multiply these two binomials together and then multiply the product of those by x plus c. So this is equal to x squared plus ax plus bx plus ab times x plus c. Then next you multiply every term here by every term here. So that gives x squared times x is equal to x cubed. X squared times c is equal to cx squared. Ax times x is equal to ax squared. Ax times c is equal to acx. Bx times x is equal to bx squared. Bx times c is equal to bcx. AB times x is equal to abx. And finally, ab times c is equal to abc. So this simplifies to x cubed plus ax squared plus bx squared plus cx squared plus abx plus acx plus bcx, which plus abc. And this can be simplified to x cubed plus x squared times a plus b plus c plus x times ab plus ac plus bc plus abc. Now we're going to try some problems using these identities. So the first one is to expand x plus 4 cubed. So this is an example of the a plus b cubed identity, which is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So in this case, a is equal to x and b is equal to 4. So this can be simplified to x cubed plus 3x squared times 4 plus 3x times 4 squared plus 4 cubed is equal to x cubed plus 12x squared plus 48x plus 64. The next problem is to find the value of 103 cubed. So to do this, you can write out 103 as 100 plus 3 cubed. So this is another example of the a plus b cubed identity, which is again equal to a cubed plus 3ab squared, a squared b plus 3ab squared plus b cubed. So in this case, a is equal to 100 and b is equal to 3. This can be rewritten as 100 cubed plus 3 times 100 squared times 3 plus 3 times 100 times 3 squared plus 3 cubed, which is equal to 1 million plus 90,000 plus 2,700 plus 9. And this can be simplified to 1,092,709. Next problem is to expand y minus 5 cubed. This is an example of the a minus b cubed identity. It is equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. So in this case, a is equal to y and b is equal to negative or is equal to 5. So this is equal to y cubed minus 3y squared times 5 plus 3y times 5 squared minus 5 cubed. Can be simplified to y cubed minus 15y squared plus 75y minus 125. Next problem is to find the value of 98 cubed. So to this, you rewrite 98 as 100 minus 2 cubed. And again, the a minus b cubed identity is equal to a cubed minus 3a squared b plus 3ab squared plus b minus b cubed. This is equal to 100 cubed minus 3 times 100 squared times 2 plus 3 times 100 times 2 squared minus 2 cubed, which is equal to 1 million minus 60,000 plus 1200 minus 8, which is equal to 941,192. The final problem will have to do with the identity x plus a times x plus b times x plus c equals x cubed plus a plus b times plus c times x squared plus ab plus ac plus bc times x plus abc. That is to expand x plus 3 times x plus 5 times x plus 2. So in this case, a equals 3, b equals 5, and c equals 2. So then this is equal to x cubed plus 3 plus 5 plus 2 times x squared plus 3 times 5 plus 3 times 2 plus 5 times 2 times x plus 3 times 5 times 2. And that's equal to x cubed plus 10x squared plus 31x plus 30. And that's the end of the video.